Hi, in this video we are going to discuss about your computer architecture and organization, the third unit. So the third unit about the processor. So how your MEPS instruction is going to flow through this processor, that overview how to build a data path, that we are going to discuss in this third unit. So before moving to the data path building, we'll see what are the introduction part. So under this introduction we are going to see how your MEP instruction going to execute and what are the steps we needed and what are the different type of early execution have been done.
So we know we have a MEPS, many instructions there. From that, I just taken a very important three set of instruction and we called as three classes of MEPS instruction. So we know that your first class will be your memory reference instruction. So what are the memory reference instruction? One will be a load, other will be a store instruction. For example, I gave you a load and your store instruction here. So this is a load. Load, what we're going to do? We'll move the content which is stored in this memory address to the register. So this is your memory location. So your 32 will be offset and your T1 will be called as base address or base register. So here LW S1 comma 32 32 of T1. So the content which is stored inside this memory location will have to move to the register of S1. So your 32 will called as offset and your T1 will called as base address or will called as base register. And when we add 32 plus T1, I can able to get your memory address. So to obtain your memory address, offset plus base address. So this is for your MEPS instruction. When you are converting from C to MEPS instruction, your memory address formula will be offset into 4 plus base address. Okay, ma. So while you are having in your MEPS instruction, your memory address will be calculated only offset plus base address. So the content will be moved to your S1. This is for your load instruction. If it is stored now, it will be reverse. The content which is stored in your register, that is S1, you have to move to the memory location, that of 32 plus T1. So store now, you have to move the content which is stored in your register to your memory location. So that will be your first class's memory reference instruction. The second class will be your arithmetic logical instruction. So we have many arithmetic and logical instruction, but we have took only 5. In that, one will be addition, subtraction, add, or, and last one will call the set less than. SLT, set less than. For example, I have 3 register, set SL, so instruction let it be set less than register 1, comma, register 2, comma, register 3. So you will compare. So what is the condition if your register R2 is less than R3, then your R1 will be set as equal to 1. So your false condition will be, if it is not satisfied now, your R1 will be set to 0. So this is your set less than condition. So that all we have taken only 5. One is your addition, subtraction, other will be your add, or, and your set less than condition. So your third classes will be your branch instruction. You have many branch instruction. Okay, we took only one set of branch instruction. One is your branch equal, other will be a jump instruction. So your branch equal to when both the condition is equal. For example, branch equal to S1 comma S2 comma label. A label will called as offset value. So when both the register are equal now, we'll go and jump to that particular label and execute the branch target address instruction. So this is a very important 3 classes. So that we are going to see in your third unit or under your data path. The next. So now you have taken your instruction as you classify into 3 classes. Now once you have an instruction, for example, I need to execute an instruction add S1 comma S2 comma S3. So For implementing this instruction, always you have two important steps. One is you to fetch the instruction, other will to fetch your operand. Here, so whenever you have an instruction, so if you need to execute certain instruction, this is a very important two step we have to follow for this three important classes of your instruction. One, you have to fetch your instruction. Fetch now you have to take your instruction. The other one, fetch the operand. Example, your R1, R2, R3 will called as operand, and this entire will called as instruction. SLT R1, R2, R3 will called as instruction. So we'll move to your first thing. Fetch the instruction. I need to fetch your instruction. You know, always your instruction will be stored in your memory. Okay, you have to take this instruction. Suppose this instruction I need to take from a memory. Now, what you needed? You need a address. For example, from the database, I need to take a particular student's name. Now, I need a register number. The same thing for instruction, which is stored in your memory. I need to take. If I need to fetch, now I need a address for that. So that address always will be stored in your program counter. The current instruction which you are going to execute, that address will be stored in your program counter, which is called as PC. So PC, now don't think of it is a personal computer. It will be a program counter in your architecture. So the program counter going to store your current instruction address, which are going to execute. That instruction address will be stored in your program counter. So once you got your address, that address will be given to your memory. That address we are going to give to your memory, and from that memory you can fetch your particular instruction, which is called as SLT, set less than R1, R2, R3. So now you got your instruction. So what is the next stage? Your second step is I need to fetch my operand, because my value have been stored in your register of R2 and your R3. So I need to fetch, this is called as operand. So I need to fetch my operand. So always this value will be stored in your registers. So your operand will be stored in your register. So you have to fetch your operand value from your register. So that will be my second step. So first, your instruction is classified into three classes: memory reference, arithmetic logical instruction, branch instruction. So once you need to execute this instruction, you have to follow two important steps. One is the fetch the instruction, other will be the fetch the operand. Fetch the instruction will use your program counter. So in your program counter, you are going to store your current instruction address, which you are going to execute. Your fetch operand, once you fetch the instruction, all the values will be stored in your register, and from that register you have to fetch your operand. So next stage, for suppose, for example, I have an instruction, I fetched my instruction, I fetch my operand. So once you fetch your operand from the register, what is the next one? I need to go for your execution. So once you, after reading your register, that is you got your operand value, you have to go for your execution. So always the execution will be done only by your ALU, arithmetic logical unit. So this ALU we are divided into for three set of instruction. First one, memory reference instruction. For memory reference instruction, your ALU used only for address calculation. So your memory reference instruction, suppose if you are using a load or store instruction, your ALU going to perform only your address calculation. So you know how to calculate your address. The formula will be offset plus base address. Offset plus base address. So that will be done by your ALU. Suppose if your instruction is arithmetic or logical instruction, your ALU will perform the particular operation. Example, it will be a AND, subtraction, or it will be addition, all will be executed by this ALU. Third category will be a branch. Suppose if it is branch instruction, you ALU go for your comparison. Comparison, now you go for your subtraction. So whenever you are using your branch instruction, your ALU go for your comparison, you go for your subtraction. You will subtract and check whether your result is 0 or not. So once your result is 0, now there will be 0 signal. The 0 signal get enabled. I'll teach you that during your data part. So once you fetch your instruction, fetch your operand, the third stage I need to execute that instruction. That will be done only by your arithmetic logical unit, ALU. So if it is memory reference instruction, your ALU will do it will be address calculation. If it is arithmetic logical instruction, your ALU will go for your file, execute the particular operation. If it is branch instruction, You ALU go for your comparison, you go for subtraction. So now you execute your particular task. So what is the next stage? You have to move either to your memory or to my registers. So that will be my next stage. Once after completing your ALU operation, you will go for either for memory or to your registers. So for example, first we will move to your memory reference instruction. So memory reference instruction, I told you have two set of instruction, load and your store. So once you calculate your address, if it is load instruction, you have to access your load or store instruction. I need to access your memory. Load instruction now, what you will do? You have to read the content which is stored in your memory and you have to move to your register. Okay, if it is load now, you have to read the content which is stored in your memory. If it is stored now, you have to write your data inside your memory. Okay, if it is load instruction, you have to read your data from your memory. If it is store instruction, write the data inside your memory. So that will be a memory reference instruction after your ALU operation. So if it is arithmetic or logical or load instruction, what you have to do, once your ALU have completed the execution, if it is arithmetic or logical instruction, your data should be the ALU result, that is your ALU result should be returned back to your register because my output will be my register. So once you calculated your arithmetic and logical instruction result, the ALU result will be moved back to your register. That same thing for load instruction. Load instruction, once you calculate your memory address, the content which is stored in your memory will be moved to your, that is the data will be written inside your memory address. Okay, so if it is ALU now, that ALU result will be moved back to your register. If it is load instruction now, okay, read the content from the memory and load it, write it inside your register. So this is your arithmetic logical instruction. The third instruction will be your branch instruction. So once you have branch instruction, you will not access your memory. So your branch instruction no need to access your memory or register anything at your last day. So once you find your branch, it is a branch instruction, you have to change your address. You have to change your PC address. So always your PC address will be incremented by +4 because each instruction can able to store 4 memory location. I told you during your first unit. So to store each instruction, I need 4 memory location because your instruction will be, your MEPS instruction will be 32-bit. Your memory location, each memory location can able to store 4-bit. So to store 32-bit, sorry, instruction can able to store each instruction can able to store 8-bit. Since your instruction is 32-bit, so it need a 4 memory location. So you have to increment your PC +4. So once you find out it is a branch instruction, so you have to change your PC address to your target address, to your branch target address. You know how to calculate your branch target address. PC +4 plus offset into 4. So that all is studied in your addressing mode in your first unit. So once you find it is a branch instruction, you have to update your PC. So you have to update your PC to your branch target address. The branch target address, your formula will be PC +4 plus offset into 4. So if it is not a branch instruction, your PC will be incremented only by +4. So this will be your next stage. So if it is memory or reference instruction, access your memory. So load now, read your data from your memory. If it is store now, write your data inside the memory. If it is arithmetic logical instruction now, your ALU output should be written back to your register. If it is branch instruction, if it is branch instruction now, you have to update your PC by your branch target address. The branch target address will be PC +4 plus offset into 4. Offset now, it will be some immediate constant value. Example, it will be 100 into 4 will be 400. So if it is not a branch instruction, a PC will be incremented by only 4. So this is the entire diagram for your data part. For your this is, I have a PC, I have instruction memory, and from this instruction memory I am going to fetch your instruction. I have a register to fetch your operand, ALU to execute the particular task, And last I told you it is going to be a data memory. So I'll tell you in your next topic, I'll tell you how to draw this data part. I'm going to tell you how you are going to need to draw this data part while in your next part.